Hello everyone, I am Janani S from Department of AIDS, Savita Engineering College. Today I am presenting our mini project titled Air Pollution Monitoring using IoT, developed under the guidance of Sri Lakshmi. The presentation covers the introduction, statement of a problem, scope of a project, methodology, output, results, and future work. Introduction of air pollution monitoring. Air pollution is one of a major environmental and public health challenges affecting urban and industrial regions. Continuous exposure to polluted air can cause serious respiratory and cardiovascular disease. Traditional air quality monitoring systems are expensive, limited in a coverage, and do not provide real-time updates. To overcome this limitation, our project uses IoT technology to monitor air quality in real time using sensors and cloud platforms. And the problem statement of air pollution monitoring using IoT. The main problems addressed in a project are first, limited real time monitoring as traditional methods provide delayed data. Second, high cost. Installation cost, which makes large scale deployment difficult. Third, health risk. Lack of real time data can prevent action, exposing people to hardest air pollutants. Fourth, data accessibility or data poor accessibility, especially in rural and semi urban areas. Our project objective is to design cost-effective, scalable IoT-based system that monitors air pollution continuously and provides real-time alerts and visualization. Scope of a project. The scope of a project includes real-time monitoring of harmful gases such as CO2, CO, NO2, SO2, and particulate matter PM 2.5, PM 10. The system collects sensor data, uploads it to a cloud, and display it on a dashboard. Alerts are generated when pollution levels exceed safe limits. This project is implemented as a prototype and does not include industrial scale deployment or advanced prediction models. These are the inclusions and exclusions of air pollution monitoring. Methodology of air pollution monitoring. Sensor selection and deployment, data collection, data pre-processing, IoT system development, integration and testing. First, sensor selection, where suitable gas and dust sensors are used. Second, data collection, where sensors continuously measure pollutant levels. Third is a data processing, which removes noise and ensures consistency. Fourth is IoT system development using Node MCU or Arduino with Wi-Fi to transmit data to the cloud. Finally, the integration and testing is performed to verify real-time performance and accuracy under different conditions. Indoor air quality index includes integrating the pollutants, gathering the standard, selecting the monitoring location, installing sensor fusion, calculating, aggregating, and interpreting IAQI. Indoor air modeling includes collecting the data, choosing a model tool, building a strong model, stimulating scenarios, Analyzing results, implement the improvements. Architecture diagram and flow. The diagram represents the architecture. Sensor collect air quality data and send it to a node MCU microcontroller. Using Wi-Fi connectivity, the data is uploaded to a ThinkSpeak cloud platform. The stored data is then visualized using a graphical and dashboard, and alerts are generated when pollution level exceeds threshold. UML diagrams. The use case diagram shows intercase interactions between the user of a system. User can review air quality data and alerts while the admin manages sensor data and monitor pollution levels. Class diagram. The class diagram represents the structure of a system, including sensor data, user, admin, alerts, and their relationships. Sequence diagram. Sequence diagram explains the flow of data from sensors to the cloud and then to the user interface step by step manner. The algorithm used in our project uses two main algorithms. First is air quality index calculation algorithm, which processes sensor data and classifies air quality into good, moderate, poor, or hazardous. The second is a threshold based air quality assessment model where pollutant values are compared with predefined standards. If the values exceeded safe limits, alerts are automatically triggered. Hardware and software used. The hardware components include MQ2, MQ7, MQ135, DHT11, Winzen EZHO7, DHT11 for temperature and humidity, and a particular matter sensor. The software tools used are Arduino IDE, Embedded C, Python, and ThinkSpeak platform for cloud storage and visualization. Implementation and code explanation. The implementation involves real-time sensor values using Arduino code. These values are uploaded to a ThinkSpeak cloud using Wi-Fi. Python script retrieve the data, calculate the AQI, and categorize pollution level. Django-based modules handle user dashboard, sensor data visualization, and alert generation. Input dataset, home page display sensor notes, and the dashboard of a code. View real-time pollution levels, AQI evaluation and alert generation. At last, add ratings page for user and the output of a program. The output includes real-time pollution readings and displayed as a graph and numerical values. Alerts are generated, pollution level become unsafe. The accuracy achieved 95% sensor accuracy, 93% data transmission success, and 92% alert efficiency, proving its reliability. Test cases. Multiple test cases were conducted to validate sensor readings, cloud connectivity, alert generation, and data dashboard display. All the test cases were successfully executed and expected output. Results: air pollution monitoring using IoT, sensor accuracy 95%, data transmission success 93%, real time alerts triggered 92%, inference and decision support 91%. air quality distribution graph. And the conclusion is the project demonstrates the IoT based air pollution monitoring is an effective solution for real time environmental monitoring. The system provides accurate data, timely alerts, and supports better decision making for public health and safety. Future work. We plan to integrate weather data, traffic density, and industrial activity for better prediction accuracy. Machine learning models can also be incorporated to forecast future pollution trends. Thank you for watching our mini project presentation on air pollution monitoring using IoT.